Ellipse Lab. This is page 36. And line number 1. Fold the paper in half, both vertically and horizontally. Label the crossing points the center. Okay, so half that way and fold it in half this way. And then this part right here, the exact center, I'm going to actually label it as center. Isn't that thrilling? Look at that. Oh my goodness. Okay, next. Place the paper, piece of cardboard. Not totally necessary here, but that would have been a good thing. Number 2, stick 2 thumbtacks so that they are about 1 inch on either side of the center. Label their locations, focus A and focus B. Okay, so from this center point right here, I'm going to use my handy dandy tape measure here. I'm going to measure 1 inch on both sides. Label those focus A and focus B. See that all right? Yep. Focus A and focus B. And on those 2 dots is where we could put some thumbtacks, but instead I'm going to have just simple pencils. And with my left hand, I'm going to hold those pencils up. And I'm going to drop my loop around here. Okay, and then let me read the directions here and make sure I'm not skipping anything. Let's see, we just did number 4, place a loop of string around the tacks or pencils here. Put a pencil inside the loop also, okay, it's just like this. Number 5, with the pencil, pull the loop taut, okay, and move the pencil around in a sort of a circle to draw the ellipse. Okay, so here we go. Here it's all loose and floppy, but I pull it tight and then I go around. So there I have my ellipse. 5A, measure the longest dimension along the fold. Okay, so I have, this is a little bit longer than this, I can tell. I can just look at it and see it's a little bit stretched out. The longest dimension in centimeters, make sure it's in centimeters, is going to be 18. We're going to be reporting these answers on Schoology. So go ahead and write down that 5A is 18. And then the shortest dimension. That is going to be 17 inches, oh, sorry, centimeters. 5B is 17 centimeters. (18 and 17). 5C, the shortest dimension is what percent of the longest dimension? Use the equation. That percent is equal to, let's see here, the difference, that's a difference of 1. And then divide by the longest side, 18, times 100. Pull up my calculator. One divided by 18 equals times 100. Whoops. 100 equals 5.5%. Let's round that to be 6%. So that's 5A, B, and C, 18, 17, and 6. You will be reporting that to Schoology in a few moments. Number 6, move the thumbtacks so they are each 1.5 inches from the center. Label these focus 2A and focus 2B. Here's 1.5. Let's see here. Okay, so here is my original focus A, but now I moved out a little bit more. And same thing with the other side. Here was my one last time, but now I'm this far. So it's a total of 3 inches from that focus all the way over to this focus. Before we just had 2 inches separating them. Okay. The longest dimension is now 16 centimeters. 7A is 16 centimeters. And the shorter dimension is 14. (7A), the longest dimension is 16 centimeters. Let's write that down on the cami. And 14 for the shorter. So the percentage is going to be found by the difference, 12, divided by the longer side, 16, then times 100. 2 divided by 16 times 100 equals 12.5. Let's round that up to be 13. So 7A is 16, 7B is 14, 7C is 13. Okay, number 8, flip the paper over and repeat the process with focuses 2 inches from the center. Okay, so once again, here's my center point, 2 inches on either side. Put my loop here. A pencil on each focus, and here we go. You can see that's a much smaller, skinnier ellipse than the previous ones. Measuring. The longest axis is going to be 14. And the more short version is 10. Okay, oh, you know what, the questions aren't exactly the same this time around. 8A, label one pinpoint as a sun's location. That is going to be one of these, a focus one or the other, not the center. The sun is going to be over here. It could have been over on this one as well, but it's at one of the focus where the pencil was. That is the sun's location. How far is the sun from the orbit's closest location? So here's the closest part on the ellipse. There is the sun, and I look at it, and it is 2 centimeters away. 8A is 2 centimeters. Label the longest dimension as the major axis and measure it in centimeters. Oh, we did that a moment ago. That was the 14. Label the shortest dimension minor axis and measure it in centimeters. We said that was 10. Label where the orbit is the fastest. Is it the point on the major or minor axis? Okay, so this is a long, skinny orbit. As it's moving this direction, it's moving towards the sun, and so it's going to get faster and faster here until it reaches this point. And then as it moves along this side of the orbit, it's getting farther and farther away from the sun, so it's slowing down, and it's slowest here. So here's where it's the slowest. And here's where it's the fastest. I'll turn it around so you can see those words right side up. Okay. So the fastest, that is on the longest side, the longest axis. So that's the major axis. This axis here, the other fold, that is the minor axis. Okay, so we've done 8A, B, and C. Number 8D, label where it's the fastest. Is this the point on the major or minor axis? The answer is it's on the major axis. 8D, major. And 8E, is it a point on the major or minor? It's on the major as well. They are both, let's see here, there you can tell. Here's where it's the slowest, and that's on the long axis, the major axis. And directly on the other side, that's where it's the fastest over here. That's also on the longest axis.